Hi, today we're starting to look at chapter 6. So in 6.1, we have exploring graphs of polynomial functions. So we'll start out with a couple definitions. So degree refers to the largest exponent in a polynomial. So for example, if we have degree 3, our largest exponent would be a 3. Or for example, this one here, y equals x to 4 plus 3x cubed plus x squared minus 5x plus 8. Our largest exponent's a 4, so it's a degree 4 polynomial. Now we also have general form. The general form of an equation is the most simplified version of it. So essentially multiplied out and like terms combined. Now we have y or f of x on one side of our equation and everything else on the other. Typically we list our terms in descending order of exponents. So linear would be y equals ax plus b, quadratic is y equals ax squared plus bx plus c, cubic is y is equal to ax cubed plus bx squared plus cx plus d. For all of them, we have a cannot equal 0 because that's ensuring that for linear, we have x to the power 1, for quadratic that we've got x squared, and for cubic that we have the x cubed term. We also have what's known as a leading coefficient. So this is the value that's immediately in front of whatever our largest exponent is. Now, it helps control where our graph starts or ends. Our end behavior refers to where the left side of our graph starts and the right side ends. So for example, our graph could start on the left in quadrant 3 and end in the right in quadrant 1. We also have what are known as turning points, which is any point where the graph of a function changes from increasing to decreasing or vice versa. These are also referred to as local maximums or minimums. So for example, I've got some graphs down here. This one here would have 2 turning points. So we have a local minimum here, a local maximum here. This one, we don't have a local minimum or maximum, so it's no turning points. Now our constant term is the only term in our equation without a variable. It is also our y-intercept. So if we look back at our equations earlier, in linear, this b value would be our constant term, that's our y-intercept. This c value would be our constant term for a quadratic and our y-intercept. And for this cubic function, this d value is our constant term and y-intercept. Now, the graphs of polynomials of the same degree have similar characteristics. So we'll look at a few different degrees, starting at degree 0. If we have degree 0, we essentially have y is equal to some sort of constant. We don't have an x in the equation. In that case, that gives us a horizontal line. So number of x-intercepts is 0 unless this line was on 0. Number of y-intercepts is 1, so it's intercepting here. And behavior, so it's going from Q2 to Q1, or if it's down here, at Q3 to Q4. Domain is all real numbers. Range, it's just going to be y equals whatever our c value is. And we can see this doesn't turn, so our number of turning points is 0. So that's what a constant function looks like. linear, which is degree 1. So something in the form of y equals ax plus b. I've graphed 2 of these out. So we've got y equals 1/2 x plus 4. So that's this one here. And we've got y equals negative 2x minus 2. So that's this one here. You'll notice each one of these has exactly one x-intercept. Our end behavior, depending on the slope of our graph, is going to be Q3 to Q1. So for example, that'd be this one in purple. So we're starting Q3, ending Q1, or it's Q2 to Q4. Our domain is all real numbers. Our range is all real numbers, and our number of turning points, straight line. So they have no turning points, so it would be 0. Quadratic functions, which are degree 2, take the form of y equals ax squared plus bx plus c. So I've graphed a couple samples here. So we've got y equals x squared plus 4x minus 6. And we also have this one, negative x squared minus 14x plus 45. Now, our number of x-intercepts can be 0, 1, or 2. You should remember that from Foundations of Math 11. Our number of y-intercepts is still going to be 1. This one had one y-intercept, and if we continued this one far enough down, it would eventually cross here. Our domain will be all real numbers, and then depending on what direction it opens, we've got y is equal or less than the maximum, so that would be for this one. So y would be equal or less than 4 in this case, or it's y is equal or greater than a minimum, so in this case it'd be y is equal or greater than negative 8. You'll notice each of these has one turning point. Next up, we have a cubic function, which is degree 3. So we've got y equals ax cubed plus bx squared plus cx plus d. So I've drawn a couple of these in. This one in orange has a negative leading coefficient, while this one in purple has a positive leading coefficient. So with these, you can see that you can have up to 3 x-intercepts. We're guaranteed to have at least one, and we can have as many as 3. Number of y-intercepts remains 1. Our end behavior could be Q3 to Q1 or Q2 to Q4. Domain's going to be all real numbers, range all real numbers, and number of turning points for a cubic function is either 0 or 2. So that's some of the properties of polynomial functions.